Astronomers using data from the James Webb Space Telescope have discovered the most distant galaxy yet confirmed to be named as Jade's GS Z130. This discovery has set yet another record for the James Webb Space Telescope. A recent study published in MNRAS used data from the James Webb Space Telescope's initial batch of observations to find a galaxy candidate Jade's GS Z130 that originated about 325 million years after the Big Bang and set a new redshift record of Z of 13.2. This discovery is really exciting since it shows the strength of the James Webb Space Telescope, which has only recently started returning its first round of data. The Cosmic Evolution Early Release Science Survey, or JADES, was designed specifically for imaging with the James Webb Space Telescope. The past few weeks have been weird, according to Dr. Rebecca Bowler, an Ernest Rutherford Fellow at the University of Manchester and a co-author of the study. She said watching all the records that stood for a long period, with Hubble being broken by James Webb Space Telescope, has been strange. Finding a candidate for a galaxy with a Z of 13.2 is fantastic. It wasn't what we had anticipated based on the preliminary data. This new study cites a dozen earlier investigations that used a combination of ground-based observations, the Hubble Space Telescope and the Spitzer Space Telescope, to measure objects up to redshifts of Z of 13. Bowler says that following the Big Bang, the universe went through a time known as the Dark Ages, during which no stars had yet been formed. This galaxy's observations forward observations to the period when we believe the earliest galaxies to ever exist were forming. There are undoubtedly many unanswered mysteries regarding how and when the earliest stars and galaxies formed, because we have already discovered more galaxies in the very early universe than computer simulations projected. Given this astounding discovery in the James Webb Space Telescope data, it's fascinating to consider how much further back in the cosmos this record-breaking space observatory can see, and whether it can actually observe the Big Bang. Approximately 200 million years after the Big Bang, James Webb Space Telescope can theoretically detect galaxies at redshifts higher than 20, according to Bowler. The Cosmic Microwave Background, or CMB, which is the afterglow of the Big Bang, is the most remote phenomenon that has been detected. The Planck spacecraft, which was deployed in 2009, has been the most notable instrument to have observed the light from the CMB over the years. The light from the CMB originates from around 400,000 years after the Big Bang. Although Webb won't be able to look so far back, it can investigate the early stages of galaxy formation. While Donnan and Bowler agree that there are no current plans for additional observations of CEERS 93316, they are optimistic that such plans will change in the future. Astronomers use the Doppler effect, a component of which is redshift, to calculate distances in the cosmos, the shifting pitch of sound waves when a loud object moves away from you and then toward you, often by an ambulance or other first responder vehicles. It's a common approach to illustrate the Doppler effect. And you must have heard about the blue shift and red shift at some point. Well, they are terms used to describe the sound waves that are emitted by an object as they move in different directions. The furthest distant object ever observed in the universe was used in this latest study, which broke the redshift. The furthest distant object ever observed in the universe was used in this latest study, which broke the redshift. Higher redshifts in astronomy indicate that an object is further away because they indicate that the universe's expansion has stretched the wavelength of light more. Recently, Hubble found the previous oldest galaxy that was known to exist. The GNZ11 galaxy was created 400 million years after the universe's creation. Only a week after the release of its first full-color photographs of GNZ11, the James Webb Space Telescope shadowed this record by almost 100 million years, indicating that Glass Z11 was created only 300 million years after the Big Bang. In reality, this most recent discovery confirms the distance of galaxy candidates using the gold standard method of spectroscopy. The findings show that Webb captured a snapshot of the galaxy Jade's GS Z130 325 million years after the Big Bang. However, the redshift of GNZ11 is calculated to be around Z of 10.957 redshift for Jade's GS Z130 is 13.2. 9 different infrared wavelength ranges were used by scientists to observe the field with Webb's NIRCam instrument. The scientists look for small galaxies that are visible in the infrared but whose spectra abruptly cut off at a crucial wavelength known as the Lyman break. Then Webb's NIRSpec instrument produced an accurate redshift measurement for each galaxy. 4 of the galaxies studied are particularly special, as they are revealed to be from an unprecedentedly early era. These galaxies were created fewer than 400 million years after the Big Bang, or about 2% of the universe's present age. By using particular filters on their cameras, astronomers can obtain reasonably accurate redshift estimations. Both GLASS Z13 and CEERS 93316's redshift were calculated using a technique known as photometry. However, photometry is not the most reliable method for determining redshift. For instance, a galaxy with a lot of dust in or surrounding it may appear further away than it is. Spectroscopy is the standard because it separates light into its constituent elements. The wavelengths originating from the galaxy's stars and those coming from dust can then be distinguished by astronomers. Spectroscopy has verified the existence of JADES GS Z130 and GN-Z11. Dr. Emma Curtis-Lake and colleagues from the UK's University of Hertfordshire found JADES GS Z130 as a result of the JADES James Webb Space Telescope Advanced Deep Extragalactic Survey. Due to the universe's expansion, since the light from the JADES galaxy that just reached James Webb Space Telescope left the galaxy, the distance between the JADES galaxy and Earth is currently estimated to be 33 billion light-years. JADES GS Z130 and other very distant galaxies are now going to be analyzed spectroscopically thanks to Webb's potent near-infrared spectrometer, NIRSPEC, which was created by the European Space Agency ESA. According to Professor Mark Makorian, Senior Scientific Advisor for ESA, this is what James Webb Space Telescope was built to do, and the European-made NIRSPEC instrument lies at the heart of it. To identify objects that could be faint galaxies developing just a few hundred million years after the Big Bang. The search for first light in the universe requires a huge frigid space telescope and a sensitive infrared sensor. The problem is that there is more hay than needles, so you have to consider a large number of candidates smearing the meager quantity of light from each one into a spectrum and using telltale tracers to check if they are the proper age and distance apart. By being able to efficiently examine hundreds of targets at a time, NIRSPEC brings a kind of cosmic magnet to the haystack. Alright guys, that wraps up our video for today. If you enjoyed watching and you found it useful, please give us a thumbs up and hit the subscribe button for more.